So we have seen the introduction to sorting set interface, correct? What is sorting set interface? The duplication of elements is not allowed. Insertion order is not preserved, but there is some sorting order. There is some sorting order. Now Treeset is an implementation class of sorted set. Okay, in middle we also have navigable set. We will learn navigable set after Treeset. Okay, so now we will see Treeset, that is the implementation class of sorted set. So we have seen some methods of sorted set also. We will see these methods in Treeset, okay, because it implements those methods. So we will see them in action when we code. Before that, let me introduce you to some important points in Treeset. The first is, it is an implementation class of sorted set and navigable set interface. Its underlying data structure is balanced tree. Okay, the tree is the data structure of Treeset. Then duplicates are not allowed, that we know. Insertion order is not preserved, but all elements will be inserted according to some sorting order. Fine. The natural sorting order that I have told you for numbers is ascending order, and for string is alphabet order. Okay. Now this is the first time in collection that heterogeneous objects are not allowed. Heterogeneous objects are not allowed. Why? We will see. The next point is objects should be homogeneous, that is fine. They should also be comparable. Now what is the meaning of comparable and why heterogeneous objects are not allowed? We will see these 2 points in very detail. Okay, the next is constructors of Treeset. Constructors of Treeset. The first one is create an empty Treeset. This is, we know, where elements will be inserted in default natural sorting order. So we have not specified any sorting order, so it will be created using default natural sorting order. We will see this first one in the code. Now the second one is when we specify some customized sorting order, then we use comparator here, correct? So we will see what comparator is. Then if you want to convert a sorted set object into a tree set object, you can use this constructor, and if you want to convert any collection into a tree set, then you can use this constructor. So first we will see the first constructor, this one, and we will see using this constructor the default natural sorting order, why heterogeneous objects are not allowed, and what do you mean by comparable. Okay, so now I will be writing a simple code using the add function. Okay, just to show the above 3 points that I've said, I will explain these 3 points using this code. Fine. So Treeset character, Treeset character is nothing but my type parameter. Fine. So Treeset equals to new Treeset. Okay, so here Treeset is nothing but this one is reference variable. Now Treeset dot add, so I'm using the add method and I will be adding a. Now Treeset dot add, using again add method, and this time I will be adding, for example, b. Okay, next one is Treeset dot add, and this time I will be adding d. Now Treeset dot add, this time I will be adding capital Z. Fine. Now Treeset dot add, finally I will add a c2, a c. So now what are the points? What are the points that I have already told you? The first point is duplicates are not allowed. Okay, I will show you that. The next point is only homogeneous objects should be allowed. Only homogeneous objects. So these all are characters, so only homogeneous objects. They should be comparable. I will tell you what is comparable. And insertion order is not maintained, but some sorting order is maintained. So now we will see this point, that insertion order is not maintained, but some sorting order is definitely maintained, and the sorting order is nothing but for characters or strings is alphabetical order. Okay, now let's see what is my answer. So as you can see, answer is Z, A, B, C, D, but I told you it is alphabetical, so Z should come at the end. But you can see the difference. They are smaller and this is capital. Now we all know the Unicodes and Sky codes, correct? So for Z, it is, for small a, it starts from 97 and the capital A will start from 65. According to code, Z will come before A. That's why Z is before A. If I am writing small z, it will definitely be after D. It will definitely be after D. Treeset dot add Z. Fine. So now it will be after D because A, small a starts from 97 and capital A starts from 65. Therefore, this is the difference. Okay. All capital A, B, C to Z completes before small a, b, c, d even starts. So therefore, all capitals are actually smaller and all smaller are actually bigger. Fine. So see the difference. So A, B, C, D, Z. This is fine. This is all in small, and because they are all in small, we can see that alphabetical order, that is A, B, C, D, Z. But this Z is bigger, and its sky value is smaller than the sky value of A. Therefore, we are seeing this difference. Fine. So take care of this point. So as now you can see, the insertion order was A, B, D, Z, C, Z, but the order we have got in the final answer is actually alphabetical order. Okay, so insertion order is not maintained. Now let me tell you the heterogeneous one. So treeset dot add, if I add 1, so it will show me an error here only. The error is we are expecting a character, but you are giving us a integer. You are giving us an integer which is not allowed. So this is the error that I get. Fine, because it is expecting a character, so it will not add an integer. Next, what we will do, let's add some duplicates. Treeset dot add and z. So I told you before also that dot add method will just return true or false. If it adds successfully, it returns a true. If it does not add successfully, it returns a false. So in this case, it should simply return me a false. Fine, because it will not add z. It will not add z, small z, because z is already present, and duplicates are not allowed in treeset. Okay, in set as a whole, duplicates are not allowed. So as you can see, it returns me a false, and it does not add the second z. So we have completed with heterogeneous point, we have completed with duplicate point, also we have completed with insertion order point. Now we have also seen our homogeneous. These all elements are homogeneous. Now let's go to comparable. Now what is the meaning of comparable that we have seen? This is the only point remaining, and this is the most important point. Okay, let's move on to comparable interface. Now let's see what I meant when I said the word comparable. So comparable is an interface present in java.lang package. So an object is said to be comparable if and only if the corresponding class implements java.lang.comparable interface. Now what is the meaning of this is, let me show you. If I am in character, and if I just show you the implementation of the character type class, in the beginning here you can see that, one second. Yes, here you can see the comparable. So it implements comparable interface. So it implements comparable interface. Therefore, all the objects of character are comparable with each other. We can compare which is greater, which is less, which is equal. Okay, because it implements comparable. I will tell you what are the methods in comparable also, but just using the word comparable as a normal English word, we can compare, that is A is less than B or A is greater than B or not. Fine. Similarly, not just in characters, but in all the wrapper class, if we are integer, if I write integer as a class here and I go to its implementation, you can see here comparable as well. So it implements comparable. It also implements comparable. Next, if I show you string, it also implements comparable. String here. One second. Go to implementation, and you can see here implements comparable. So all the classes which implements comparable interface are those objects becomes comparable objects. Okay, we can compare these objects with each other. Fine. So even string buffer. So here in string buffer, the comparable interface was not implemented before. It is just implemented in the latest version of Java. Okay, so if you are reading some online text where it says that string buffer does not implement comparable interface, but it does in the latest version of Java. It does not. It did not do that few years back. Okay, so string buffer does this also. Fine. So as I have told you this line, that an object is said to be comparable if and only if the corresponding class implements java.lang.comparable interface. So I have shown you the classes that implement comparable interface. There are more also. So only those classes objects are comparable. Fine. Now it contains only one method, that is compare to method. That which method compare to, and which returns an integer, So the syntax of compare to is object1 dot compare to and object2. So it returns negative if and only if the object1 has to come before object2. In sense, object1 is less than object2. Now if object1 has to come after object2, in sense object1 is greater than object2, then it will give me a positive value. Okay, a positive integer will return, and it will return a 0 if object1 is equal to object2. Now let's test this. Okay, we will simply write a small code for this one. So let's test what we have seen in comparable slide. So let's now test that. So we will just simply s out a dot compare to b. Fine. So a should come before b, that is a is less than b. So the answer should be simply a negative value. The answer should be a negative value. Next we will compare. As you can see, the answer is negative -1. So next we will compare, for example, a dot compare to z. A dot compare to z. So answer again should be a negative value, but it is not that every time -1 will come. So here's time it is -25. Fine. Now s out, let me compare z with b. Z dot compare to b. Now z should come after b, so answer should be a positive value. Answer should be a positive value. C, it is 24. So after that, now what we will do, we will compare two equal values. So for example, C dot compare to C. Okay, so now the answer should be equal, that is 0, because both are equal, both characters are same. So answer is 0. So I hope you understood compare to method. It is easy. Now, so let's see how add works. So first we have to add A. Fine. So at moment tree is null, so A will be added at the root. Fine. Then comes B. So now A is compared to B. A is compared to B. Or you can say B is compared to the root. Sorry, the B is compared to the root. So B is compared to the root, that is here. Now what will happen when B is compared to the root? B should come after A. So the compare to method will return a positive value, and B will be added after A. B will be added after A, and this now will be my output. Correct? Now D should come. Now D will be compared to B. Now what will happen is D should come after B. So it will be added after B. Next, Z is coming. Now Z should come before A. Fine. So it will be added before A. So compare will return nothing but a negative value for Z. For C again, it will return me a negative value. Why? It will be compared with D. So since for D it will come negative, so it will come here. It will compare with B. For it will come positive, so it will come here, and it will be inserted between B and D for C. Correct? So this is how Treeset, the compare to method helps Treeset for comparing different values. Okay, but the value should be homogeneous. Now I think you understood why that line was written, that the object should be homogeneous as well as comparable. Now one more point that I would like to add is null. What happens if I try to add null? So there is no compile time error in this, but it will show me a runtime error. Why? Null cannot be compared to any of the characters above. Therefore it will return me a null pointer exception. Okay, so null cannot be added into my tree. Fine. So this was what a comparable is, but what we have seen is now only the first constructor, that is the default natural sorting order. What if we do not want default natural sorting order but some customized sorting order? For that we will use comparator. Okay, so next we will see what is comparator and what is the difference between comparator and comparable. I have already told you actually the difference. Comparable is used when default natural sorting order is there. Comparator is used when a customized sorting order is there. Okay, so next we will see what is the meaning of comparator.